Good afternoon. So our discussion is about the first part of the chapter, and that is only concerned with symmetry. Although the name of the chapter is symmetry, but there are two aspects of it. One is about symmetry itself. The second is about circle and its theorems. Circles and based on theorems based on circle, we have done that already. I'll put the video, upload the video immediately after recording this. But that video is already recorded. Now this is what we have as symmetry. And let's see it. This is only the PDF that I have generated by using the textbook itself. If you take a rectangle, then there are two lines of symmetry. This you can fold across this line and these two sides will perfectly match. Or you can fold across this line and the two halves will perfectly match. Similarly here, this is an equilateral triangle, so there are three lines of symmetry. And you can check 1, 2 and 3 lines of symmetry. In a square though, this and this is of course there, but even the diagonals are the axis or lines of symmetry. And in a circle there are infinite lines of symmetry. Every diameter is an axis of symmetry or a line of symmetry. So based on this we'll solve exercise 19.1. The question says which of the broken lines are the lines of symmetry? See, this is surely a line of symmetry because these two halves will perfectly coincide. Will they perfectly coincide? Will EF be a line of symmetry? I'm not sure about it because this is a straight line and the line is tilted, so it will go like this. This point will come somewhere here. So EF may not be the line of symmetry. GH may not be a line of symmetry, but AB is a line of symmetry for sure. And CD is also a line of symmetry for sure. So I think EF and GH are not lines of symmetry. Here, this is surely a line of symmetry, this is surely a line of symmetry, but diagonals may not be. This is not a circle, this is the ellipse. Isosceles trapezium. By the meaning of the word isosceles in isosceles trapezium, these two sides are equal. If these two sides are equal, their base angles will surely be equal. So this will be a line of symmetry for sure because these two halves will perfectly coincide, they are perfectly equal anyway. This is of course not a line of symmetry, we see that. This not a line of symmetry. Only one. AB is the only one line of symmetry. Rhombus, I think the rhombus will this be a line of symmetry? Right now I don't think so because this point B will come somewhere here and E will come somewhere here. Same with this. But then this diagonal and this diagonal, both the diagonals are surely the lines of symmetry. Taurus, a CD can be a line of symmetry. You imagine that this is what you see through a pipe. There is a small hole here, and there is the thickness. Only this thickness is seen. So if you can cut along this line, this will perfectly match. If you cut along this line, this will perfectly match. But EF and GH are not lines of symmetry at all. L shape, you see that this I think is a line of symmetry. They will perfectly match. This is not a line of symmetry. Recular pentagon, this is a line of symmetry. AB. GH is also a line of symmetry. CD is also a line of symmetry. But EF is not a line of symmetry. Sketch the following polygons and investigate to see how many lines of symmetry each one has. Copy and complete the table in your results. Square will have how many? You can do that. There is nothing great about it, there is nothing very difficult about it. Copy these diagrams and draw all possible lines of symmetry. This will be a line of symmetry, surely vertical line. This will be surely a line of symmetry, horizontal line. Will this, see this is, join this point with this point, then this might be a line of symmetry as well. Join this point with this point, and this will be a line of symmetry as well. Same with this. यहाँ पे एक ही है, this is only one line of symmetry here, only one. This is 1, this is 2, this is 3, and this is 4. 4 lines of symmetry here. I hope you understand this. 1, 2, and this 3 as well, and this 4 as well. Same was applied to here, 1, 2, and then the 3, and then this one 4. Same here, 1, 2, 3, 4. 1, 2, 3, 4. Try solving. Should there be any problem, please get back to me. I'll help. No problem. Rotational symmetry. Rotation is about turning. So if you turn a particular object, you start from here and you turn it. It becomes this. Don't worry about the star. The star has been shown so that you know the star has come from here to here. So there is a 90 degree of rotation that has taken place. The star has come from here to here. So 180 degree rotation has taken place. So 270 degree and 360 degree rotation. But in all of this rotation, after 90 degree, after 180 degree, after 270 degree, after 360 degree, the basic shape remains the same. It looks the same. If you ignore the star, the position of the star, everything else is perfectly same. The square fits exactly onto itself 4 times in a rotation. When it has turned through 90 degree, 180 degree, 270 and 360 degree. So 4 times in one rotation, it fits with the original shape. So the order of rotational symmetry is 4. Order of rotational symmetry is how many times during one complete rotation, how many times you get the shape absolutely perfectly matching with the original shape. State the order of rotational symmetry of each of the polygon. If you rotate it 90 degree, this will not look the same because the length is more and the breadth is less here. Rotate to 90 degree तो length ऊपर ऐसा हो जाएगा. 180 degree surely and 360 degree. So there are the order the order of rotational symmetry is 2. In this case it will be 5. You rotate it to 72 degree, it will look like this. Again 72, 144 will look like this. Again 72 as a 5 times. This I think only 1. After a complete 360 degree rotation it will look like this, otherwise not. This will have 6 rotation, 6 times. Rotate to 60 degree, 60 degree, 60 degree will look the same. This will look the same only after complete with 360 degree of rotation. Same here, this will look the same after 360 degree of rotation. Same here, same here. We can fill this. Triangle will have how many rotational symmetries? If you are talking about a equilateral triangle, if we are talking about an equilateral triangle, then the rotational symmetry will be also 3. Order of rotational symmetry. Quadrilateral, if it is a square, the order of rotational symmetry is also 4. Yeah. Pentagon, regular pentagon will also have 5. Hexagon will have 6, and so on. Each shape, whatever. Let's see. We can solve this. The wheels, rotational symmetry. There are some questions. Alloys. State the order of rotational symmetry. See, it's not only about the rim. It's also this line. These lines will also match. So this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 different lines. So there are 10 rotational symmetries here. You can check for others. Symmetry in 3 dimensions. The plane symmetry, in the sense that if you take this into consideration, the cube, then this central plane in between that, see, ये from this to this, यहाँ पे center point में, इसके center point में, यहाँ से इसके एक plane जाएगा, ऐसा plane. So this was the cube. तो ये क्यूब की यहाँ पे इसके इस मिड पॉइंट में से ये मिड पॉइंट ये नीचे वाला इसमें से जो प्लेन that will be the dividing these two cubes into equal halves. One cube into two equal halves. That will be the axis of symmetry, line of symmetry. Also this one and also this one. So there are three. For a sphere it will be infinite again. Check. Here are two planes of symmetry in a cube. A cube has 9 possible planes of symmetry. Make sketches to show the other 7 planes. 9 मतलब एक 1 है, ये diagonal है 2. ऐसे कितने, how many diagonals are possible? There are 3 lines of symmetry, planes of symmetry that you have seen, 1, 2, 3. And फिर ये जो है ना, ये diagonally cube, diagonal जाने वाला plane, this is 1 from here to here, 1. ऐसा भी जाएगा 2, यहां से इस एज से स्टार्ट होके इस एज तक भी आ सकता है ऐसा. सो लाइक दिस. सो 2 इन दिस वे, लाइक दिस, एंड ऊपर से लाइक दिस, 2 इन दिस वे, एंड देन लाइक दिस एंड लाइक दिस, 2 इन दिस वे. सो ये प्लेन एक यहां से ये इस पॉइंट से यहां तक आएगा दूसरा. फिर यहाँ पे ये इस सरफेस में से ऐसा निकल के ये पीछे के सरफेस पे जाएगा तीसरा, ये ऐसा जाएगा चौथा, और फिर यहाँ पे पांचवा ये ऐसा एंड ऐसा चढ़ा. 6 different planes like this and 3 planes like this. 3 planes we already seen. Total 9 planes. How many planes of symmetry? One center में है ये ऐसा. इसके अलावा कोई है ना? यहां पे भी सेंटर में होगा, ऐसा भी जा सकता है, ऐसा होगा तो इनफाइनाइट होगी, क्योंकि ये सर्कल के डायमीटर क्या बन जा रहा है, इनफाइनाइट डायमीटर होगा. तो ये कहीं से भी जाएगा, सेंटर पे से, सेंट्रल एक्सिस पे से पास होने वाला कोई भी प्लेन, देन देयर आर इनफाइनाइट. इसका भी बस एक ही होगा ऐसा. अच्छा यहाँ पे ये भी होगा ना, देखो ये लाइन फ्रॉम हियर टू हियर, ये मिड पॉइंट ज्वाइन करने वाला लाइन, और ऐसे ही आगे पास करके चला जाएगा तो भी 1, 2 और ये 3 और फिर चलते यहाँ से 4, ऐसे 4 प्लेन करेंगे. आई होप यू अंडरस्टैंड दिस. देयर विल बी 4 प्लेन्स. इसके यहाँ से एक ही जाएगा ऐसा प्लेन, प्रोवाइडेड दीस टू लाइंस आर इक्वल. तो यहाँ से 45 डिग्री पे जाएगा एक ऐसा लाइन, एक ऐसा प्लेन जो ऐसा काट करके जाएगा, या फिर यहाँ पे बीच में से एब्सोल्युटली ऐसा कट करेगा. 2 प्लेन्स. इसका चेक कर लो, इसका भी चेक कर लो. रोटेशनल सिमेट्री फॉर 3 डायमेंशनल ऑब्जेक्ट्स. देखो यहाँ पे डॉट है, आफ्टर यू रोटेट इट थ्रू 60 डिग्री, डॉट यहाँ पे आ गया. अगेन रोटेट थ्रू 60 डिग्री, तो डॉट यहाँ पे आ गया. 120 डिग्री एंड देन रोटेट यहाँ पे आके डॉट यहाँ पे आएगा. 120 डिग्री, 120 डिग्री, 120 डिग्री, टोटल 360 डिग्री. 120, एक और 120 मतलब 240 टोटल, और टोटल 360. ऐसे 3 बार ऐसा होगा. वैसे इनका क्या होगा यार, ये तुम लोग सॉल्व कर लो. आई डोंट वांट टू हेल्प दिस इज वेरी सिंपल. एंड वंस यू आर डन विद दिस, देन वी स्टार्ट विद द सिमेट्री प्रॉपर्टीज ऑफ सर्कल्स. And we have done this video. Perpendicular bisector. Let's solve the basic exercises based on this. Yeah. Calculate the length of the chord AB. X is the midpoint of AB in each case. X is the midpoint. ये 6 है, ये 6.5 है. This is the Pythagoras theorem. This will relate this ax be called as h, small h. So we'll have h square plus 6 square equal to 6.5 square. So this will be 2.5 I think. And ये Pythagoras से solve करके आ जाएगा. ax का वैल्यू 2.5 और ये midpoint होने की वजह से total ab होगा 2.5 into 2 मतलब 5. सिमिलरली ये 8 17 है तो ये 15 आएगा पाइथागोरस ट्रिपलेट से, ये 15 आएगा तो ये टोटल 30 आएगा. ये पाइथागोरस का एप्लीकेशन है यार, दिस इज वेरी सिंपल. In the P is the point inside the circle whose center is known. Describe how to draw a chord that P has its midpoint. हाँ, this you can check. P should be the midpoint of the chord. तो पहले सेंटर और P को ज्वाइन कर लो और फिर उस ज्वाइन से परपेंडिकुलर लाइन बना लो P में से पास होने वाला, वो कॉर्ड बन जाएगा. सेंटर O है और पॉइंट कोई भी एक पॉइंट P है, O और P को ज्वाइन कर लो और फिर OP को परपेंडिकुलर लाइन बनाओ, स्टार्टिंग पासिंग थ्रू P में से जाएगा और OP को परपेंडिकुलर होगा, ऐसा लाइन, वो होगा कॉर्ड. AB and CD, AB and AD, sorry, AB and AD are the tangents to a circle. ABC, ABC is a straight line. Calculate the angle X. This line is passing through the center O. ये 47 डिग्री है. ये दो लाइंस इक्वल होंगे. ये तो 90 होगा ना पूरा का पूरा. ADC, the center will be 90 degree passing through the center, मतलब ये रेडियस है और ये टेंजेंट है, टेंजेंट रेडियस आर 90 डिग्री. ये 47, ये 90, 47 प्लस 90 137. ये बाकी 180 में से सब्ट्रैक्ट करके x आ जाएगा. Find the length of AO. Here, this AO will be perpendicular to this tangent 12 centimeter. So 12 square plus radius AO का square is equal to 15 का square. You can find out this. This should be 9, I think. Check कर लो क्या आ रहा है. AB is equal to CD. AB और CD equal to करना है. यहाँ पे ना इसमें से ये अगर हम लोग टू कॉन्सेंट्रिक सर्कल ABCD आर इन द ऑर्डर ABCD. अब यहाँ से अगर मिड पॉइंट पे लाइन बनेगा तो ये यहाँ पे मान लेते हैं M बन जाएगा, तो ये इसका भी मिड पॉइंट होगा AD का और BC का भी मिड पॉइंट होगा. ये यहाँ पे अगर परपेंडिकुलर लाइन बनेगा तो इससे हम लोगों ने क्या हो गया फिर, दिस मींस दैट AM इज इक्वल टू MD एंड BM इज इक्वल टू CM. सब्ट्रैक्ट कर लो, आ जाएगा ये इज इक्वल टू CD. देखो I will draw this. This is point M and this is from the center and drawn a perpendicular. So that means the chords are bisected. So M is bisecting chord AD. इसका मतलब है AM is equal to MD and M is also bisecting chord BC for the smaller circle. So we have BM is equal to MC. Now from the first equation subtract the second equation. I get AM minus BM is equal to MD minus MC. AM minus BM, AM में से BM गया मतलब AB बचा and MD minus MC मतलब CD बचा. So AB is equal to CD proof हो गया. This was not difficult at all. Calculate the angle X. This is 83 degree. This is center. These two will be radii. तो ये और ये इक्वल है, मतलब ये और ये दोनों एंगल्स भी इक्वल होंगे. दिस एंगल एंड दिस एंगल. Let this angle be Y, this angle be Y. Let's do this. So you see this is Y and this angle will also be equal to Y because in the triangle OBA, OB is equal to OA because this is the radius of the circle, both of them are. So the base angles will be equal because it's an isosceles triangle now. So 83 plus 2y is equal to 180 degree. So 2y is equal to 97 degree, and y will be equal to 97 by 2 is 48.5 degree. Now x and y are together are equal to 90 degree. Why? Because this is tangent and this is the radius. So the total angle must be 90 degree. So x plus y is equal to 90 degree. So x is equal to 90 minus y is 41.5 degree. AD is diameter, angle ABC is 40 degree, BCF is a tangent, BAE is also a tangent. Explain why triangle ABC is isosceles. ABC is very simple. This AB must be equal to BC because the two tangents drawn from an external point are equal in length. So if these two lines are the same, having same length, AB is equal to BC, then the triangle ABC must be an isosceles triangle. It is done. Calculate the size of angle CAB. CAB. Now this will be 90 degree. No, this will not be 90 degree. Sorry. CAB. Acha, okay. So this angle is X, let's say. This is X. So this will also be equal to X because we know that ABC is a isosceles triangle. So the base angles will be equal. X plus 40 degree is 180 degree. 2x plus 40 degree is 180. 2x is equal to 140. X is equal to 70 degree. This is 70. This is 70. Done. DAC. DAC. Now this total angle would be 90 degree. इसमें C है 70 तो ये 20 होगा. ADC. If this is 20 degree, this is 90 degree. ना एक बड़ा ये 90 होगा क्या? ये तो 70 है. This we have determined that this angle is 70 degree. This is 70. This is 20. This angle ADC. See, this will be 90 degree. AC. ये जो एंगल है ये एंगल this will be 90 degree. ACD. Why? Because this is the diameter AD, and if AD is diameter, then this is the angle in a semicircle. Angle in a semicircle is a 90 degree right angle angle. So this is 90, this is 20, this has to be 70 degree. Total is 180 degree right angle. It's not very difficult at all. If you apply the same logic, correct logic, you get it. These theorems we have seen that if this is x, this will be 2x. If this is x, this will be 2x. It doesn't need about, it's not about intersecting, not being intersecting lines or anything like that. It's not nothing to do with that. This is like, this is x, this will be 2x. You check if this angle is x, this is formed between point A and B. तो A और B के बीच में सेंटर में बना हुआ एंगल 2x है. Please check. Solve the further exercises 19.7 and so on. They are not difficult at all. I tried that. It's very simple. So you can just solve. And should there be any doubt, please let me know. The theory part is completely done from this chapter in the video that I had recorded just before this one. I am putting this video and the previous video both together online immediately after this. So this should not be a big deal for you. I hope you understand this. Alternate theorems, alternate segment theorem is an important theorem. Alternate segment theorem. I have explained in that video, and you can solve the questions based on this. Okay. I hope you get this. I hope this works, and I'll take the next chapter after this, and I'll record those videos tomorrow. Thank you.